A microscope allows us to view tiny structures of a specimen by using objective lenses. But when we zoom in to view finer details, the field of view is now limited to a small region. What if we wanted a high-resolution image but still covering a wide field of view? Fourier Ptychography microscopy, or FPM, involves taking multiple low-resolution wide field of view images of a sample illuminated at different angles using an LED array. The resulting images would contain additional edge information that can be combined to form a high-resolution image. The principle behind this is that when a sample is illuminated, this results in a diffracted spectrum that is filtered by the aperture of the objective lens. The key to this method is that for off-axis illumination, the diffracted spectrum results in a shift with respect to the on-axis illumination. This means if we combine these multiple angled illuminations, we can reconstruct a larger spectrum resulting in a higher resolution image. The reconstruction process utilizes this simple principle where we use the individual images to reconstruct a larger spectrum. This is able to improve the resolution of this red blood cell image from this to this. As a bonus, this also recovers the phase of the image. We usually take 50 to 200 images, so if one image takes 50 milliseconds to capture, the entire acquisition takes around 3 to 10 seconds. This triples for an RGB image, preventing real-time reconstruction. Therefore, it is crucial to automate this process to reduce unnecessary delays. My work presents the development of a turnkey Fourier Ptychographic microscope where I use a biological microscope, then added a camera and an LED array. The acquisition is automated by using a microcontroller to send digital signals to the camera and the LED array. This minimizes the delay to less than a millisecond. This shows a real-time acquisition of 49 images in under 2 seconds. To learn more about the details for creating a successful setup and to see more results, visit me at my thesis defense this June 2024 or contact me by email. See you there!